Hello everybody. In this section we're looking at similar polygons. So what is a similar polygon? Well, two polygons with the same shape but not the same size are similar. So I'm going to make a triangle here. I'm going to copy it, shrink it, and rotate it. So triangle ABC and triangle EFG all have corresponding angles that are congruent, and the corresponding sides are proportional. So therefore triangle ABC is similar to triangle EFG, and this little squiggle sign here means similar. Example 1. Suppose triangle ABC is similar to triangle JKL based on the similarity statement, which angles are congruent and which sides are proportional. Okay, so that would mean that angle A would go with angle J, angle B would go with angle K, and angle C would go with angle L. So those pairs are congruent. And now we're going to write a proportional statement. So AB corresponds to JK. So AB over JK equals BC corresponds to KL. So BC over KL. And AC corresponds to JL, so that equals AC over JL. So there is our proportional statement. Okay, so let's see how we apply this idea in example 2. We've got two quadrilaterals. MNPQ is similar to RSTU. So all the corresponding angles are congruent and all the sides are proportional. So we can see this in the way it's written, that M has to correspond with R. So angle M is the same as angle Z in the drawing, has to be congruent to angle R, which is 115 degrees. Okay, so we can see that MN goes with RS here, MN over RS. So I know MN is 18 and RS is 30. And that would be congruent to another proportional. We can say NP to ST. And NP I don't know, that's X. But ST I do know is 25. So when I substitute what I know in here, I get this proportion here. And I can solve for X. So let's simplify here. 18 over 30 simplifies to 3/5. Multiply 25 to both sides to get X by itself. And I get 15. Now y I don't know also, and it's a side TU. So T to U corresponds to P to Q. PQ is 15. So TU to PQ has to equal RS to MN. So substitute what I know. Y over 15 equals 30 over 18. 30 over 18 simplifies to 5/3. Multiply 15 to both sides. Y equals 25. And we're done. Example 3, ABCD is a rectangle with length 12 and width 8. UVWX is a rectangle with length 24 and width 18. Are these two rectangles similar? Well, let's take a look at how we solve this. 1, the corresponding angles must be congruent, and in this case they are. They're all 90 degrees. 2, the corresponding sides must be similar. So that must mean that the proportions must be the same. So BA to VU must be equal to BC over VW. Those are the corresponding sides of each corresponding rectangle. So I substitute my knowns in this proportion. I get 8 over 18 equals 12 over 24, which simplifies to 4/9 equals 4/8. Not equal, so it's not proportional, therefore not similar. So let's talk about what a scale factor is. In similar polygons, the ratio of one side of a polygon to the corresponding side of the other. That would be the scale factor. So in example 5, we have ABCD is similar to AM and P, I want to find the scale factor and the length of BC. So side CD corresponds to side NP. So the scale factor would be 45 over 30, or 3/2. Side BC corresponds to side MN, so that must mean if I want to find what side BC is, it's unknown, and I multiply side MN times the scale factor, it will give me side BC, which 40 times 3/2 is 60. So if you know the scale factor, you can use that to find an unknown corresponding side of another side of a polygon. So in example 6, find the perimeter of ABCD and AMNP in the figure above. Then find the ratios of the perimeters. So we're going to assume that these are right angles here, that these are rectangles. So the perimeter of ABCD would be twice 45 plus twice 60, which is 210. The perimeter of AMNP would be twice 30 times plus twice 40, which would be 140. So the scale factor that we saw before is 3/2. So the ratio of the two perimeters would be 210 over 140, which is 3/2. Note that we can also write a ratio as the reciprocal. We could say that it's 2/3 or 3/2. We just have to make sure that we multiply the correct ratio if the figure is larger or smaller. Just depends on which way we're going. Okay, similar polygon perimeter ratio theorem. Okay, just from above, we saw that the ratio of the perimeters of two similar polygons is the same as the ratio of the sides. So that meant that the scale factors of the perimeters were also the same. Example 7, triangle ABC is similar to triangle MNP. If the perimeter of triangle ABC is 150, and we know that AB is 32 and MN is 48, find the perimeter of triangle MNP. Okay, so look, we know that the scale factor equals MN over AB because those two sides correspond. So we can see here that 48 over 32 simplifies to 3/2. So there's my scale factor. Now we know the perimeters are going to be proportional to the scale factor. So I can take the perimeter of triangle MNP and set that equal to perimeter of ABC times the scale factor. So the perimeter of ABC is 150, the scale factor is 3 over 2, and I multiply them, I get 225. So look, we know that triangle MNP is the larger triangle because MN is 48 and AB is 32. So when we multiply 150, we have to multiply it times 3 over 2, not 2 over 3, because that would give us a smaller perimeter, and this one's going to be bigger. Okay, so I hope that makes sense. Go ahead and try the practice set. See you next time.